So we're gonna follow up with the enteric lab that we did last time. We had five different tests that we did, right? The first were the phenylalanine deaminase test, right? And so they took my reagent today. Harlow, will you grab 10% ferric chloride for me? I usually have everything set up and they just took, yeah, one of those. So I'm gonna hold one of them, and then the set's gonna add the ferric chloride about half a squirt into the media, and then we're gonna roll it around on the slant. Okay. Look at that pinky powder. Isn't that nice?
Half of it?
Squirt it. Okay, good. Okay. Trade me. And then do that. And I'm going to roll this around here like this. Everybody's chewing stuff.
Just throw it away.
Did you? Okay, roll. So now, hold them together. And hold them like here. And put the slant all facing the same way. Okay. So now, if you look at these, can you appreciate? So you're going to have to be like Vanna White. You're going to have to go around over there panoramically. Yeah, okay. And then go that way. So one of them is green, and the other one is not green. It's orangey, rusty, yellowish looking, right? So the one that's green is positive, right? And the one that is orangish, yellowish is negative. Okay? You can put those down. Anybody have questions about the phenylalanine deaminase test? Okay. So, I hold the other three up so everybody can see them. So this is the decarboxylase test. Are these tests valid? Answer?
Yes,
Why?
because we
No. Because the mineral oil makes it anaerobic, and they have to be anaerobic to be valid. Hold them up again, please. So, which one of these is positive? The purple one. Yeah, if you're pointing at it like that, like, okay, which one are you pointing at? The purple one. The purple one is positive, the others are negative. And every single organism is going to have a different biochemical profile. You can see that one of those is, but on this one you can appreciate that they're all positive. Okay? So every one of them is going to have a different biological profile. Okay, so in just a minute you'll come pick up your tubes and you'll go take results. Remember, after today there's only one more lab that you need a pre-lab and a lab report, and after that the lab is going to change so that you're going to be doing things individually. Okay? So now, we're going to talk about the plates. On the plates, I'm going to have to use these because they're a little bit better. The plates, this is EMB. So if we hold this up, you can appreciate that this one is kind of a purplish reddish color. That one is a lactose fermenter. This one has got a metallic green sheen on it. That is also a lactose fermenter, but it's E. coli. And the other two grew, but they didn't really develop any color. You want to hold that up and you just kind of do this like that. So kind of do that so they know where to look. And so, yeah. And so panoramically, right, show them. Okay? So,
it's reddish, but still it's negative.
yeah, it's still negative. If the reddish is coming from the media only. Okay, so you can put it down, and then I want you to show them E. coli all by itself. So this is E. coli all by itself. It's metallic green, it's quite beautiful. And if you smell it, it smells very sweet because it's been fermenting. It might even remind you of bread that you made. Let me make sure, just to make sure. Yep. So it's, I mean, every time I go by the H-E-B bakery, I'm like, oh, fermentation. So that's really good. That's great. Okay? Any questions? So, yeah.
What causes the breakdown? What causes that color like that?
So it is a combination of an enzymatic reaction, the acids that are being produced, and the way they interact with the eosin and the methylene blue. But only E. coli does it. There's an enzyme, it has a name, do you want to know? It's called umbriase. You won't need it to know that for the exam. But it's a pretty cool enzyme. This particular test, EMB, eosin methylene blue, is designed to pick up E. coli in water systems because E. coli is an indicator for fecal contamination. So I don't know how many times you might go to a lake or something like that, but a lot of times if you go to the lake, at the entrance of the park to the lake, there's this blue flag that's kind of flying over it, and it's got these little waves on it, and that means the water's been tested and the water quality is good. Right? Almost nobody pays attention to it. Right? As a matter of fact, I was like, "Where's the flag?" And I went inside and said, "Y'all aren't flying the flag." He says, "Oh, I forgot," and so they went out and put it up, right? Because people like me want to see it. But almost nobody pays attention to it. They would not open the park if the lake was bad. Okay. All right. Any questions? Okay, let's look at this one. Oh, this is really cute. I don't know who did this, but it's cute. Let's show them. That's y'all. So these are lactose positive. This is hecto and enteric agar. The orange or the yellowish are lactose positive. The other ones that are bluish green but have black precipitate in them. Here, you can hold these and show them around. That's a really nice plate. Those are, put it on top so people can see it.
The blue and green is
The
negative?
blue-green on top. Because those are the more important ones. We don't, if we see yellow or orange on hectone, we don't care. It's normal. But if we see the non-lactose fermenter with H2S, it needs to be further worked up because it might be salmonella. Okay? Good? This is from the morning class. This was a really great plate that Maria did isolation for it. And here you can see a really nice 4-quadrant streak for isolation with salmonella. Right? It's beautifully grown on here. If you want to look at this, I've got it over here. Sometimes when I find pretty plates, I like to take a picture of them and use them for the practical, and so they sit over there. Okay? Good? All right, so now we need to go to these guys, which we'll use that because it's got heart again. So if we look at this plate, this is McConkey agar. So if you point to the heart one for everybody, the heart one is lactose positive because it's pink or red, right? Now point to the other pink one that's got a whole bunch of cloudiness around it. This one is also a lactose fermenter, but here you can see there's something very different. If you turn it around for them, Lisette, so they can see the cloudiness. The cloudiness, is that a boat? What is that?
Looks like
I
wood.
don't know what I was trying to do.
Okay, it looks like a boat, but the cloudiness indicates bile precipitation. That's lactose positive, but the organisms have produced so much acid that it's precipitated out to bile salts, and you see that as cloudiness around the column. Then if you point to the one that's grown but doesn't have a lot of color to it, right? Oh, well, okay, that doesn't make sense at all. Let's see.
This one has no color to it.
Oh, we put the wrong organisms on there. Luckily for you, I have a really great plate here. This one, again, this is lactose positive, right? This is lactose positive with bile precipitation. This organism is growing. This is salmonella, but it has no pink color to it, so it's lactose negative. And this other thing on here, Enterococcus faecalis, which almost nobody used, isn't growing at all. Why? Because it's gram positive. And so if it's gram positive, these plates will only allow for gram negatives to grow. So if you put something on here and it didn't grow, then it's not a gram neg, it's a gram pos. And you don't really care about it if you're looking at enterics. Okay? Good? Does anybody have any questions about anything we did last time? So we're running ahead of schedule. So why don't we say by 12